Good morning, students. It's very good to see you after the weekend. Today is 13th April 2020 and the day is Monday. And these are the online classes for the students of class 11, class 12 and the improving students here at the Navigator Science School and College, Thatta. We have so far in the previous week covered phenols and ethers, which included one test as well, and the students' response was amazing. Today, we are going to start our session with the carbonyl compounds. It is also the part of the 9th chapter of the organic chemistry of class 12, which is the study of compounds, carbon compounds with oxygen-containing functional groups. There are 7 compounds, there are 7 families in the organic chemistry that we will discuss in this chapter. The alcohol, the phenol, ethers, aldehydes, ketones, carboxylic acids, and esters. We have discussed the alcohols and phenols and ethers previously. Today, we will start with the carbonyl compounds. Now, what are carbonyl compounds? The aldehydes, which is a very important family of organic compounds, their functional group includes carbonyl group. This carbonyl group is also present in ketones, and it is also present in the aldehydes, ketones, carboxylic acids, and even esters, and more compounds in the organic chemistry. There could be hundreds of compounds, but in our syllabus, we are targeting mainly these compounds. So let me first introduce you guys to the carbonyl. What is a carbonyl group? See, when carbon is bonded to oxygen, the double bond, with 2 valencies open for further bonding, then such compound is called carbonyl compound. I mean to say, when carbon is bonded to oxygen with a double bond and the remaining 2 valencies are still open for further bonding, then this group is called carbonyl. This is a carbonyl group, what you are seeing at your screens. Carbon bonded to oxygen with a double bond. This group is called carbonyl group. Now, carbonyl group can be represented as C double bond O, or we can also show it as CO. All right? Or this double bond can also go down. So carbonyl is not a compound. Carbonyl is a group which is present in different compounds. And what compounds in this chapter are basically carbonyl compounds? So aldehydes, they top the list. They are carbon compounds whose functional group includes carbonyl group. The second is the ketones, another important organic family. They also contain a carbonyl group in their functional group. The third is carboxylic acids. These are also important family of organic compounds, and carbonyl is also the part of their functional group. And finally, esters. Esters, they also contain a functional group which contains a carbonyl group. So all these 4 families in our syllabus, the remaining families in our families of organic compounds in our syllabus, aldehyde, ketone, carboxylic acid, esters, they share the same functional group, which is the carbonyl group. But there are few differences, very slight differences. Now, the differences are based on these two valencies. You can see, and you know that carbon is tetravalent element. Carbon can make 4 bonds. So in the carbonyl group, carbon has made 2 bonds with oxygen, sharing the 2 electrons or overlapping via sp2 hybridization. Now these 2 remaining valencies of carbon, how they are satisfied will convert a compound into an aldehyde or a ketone or a carboxylic acid or an ester. So all these compounds basically contain this group with some slight changes. Now I will go one by one, and I'll start with aldehydes. I'll explain to you guys what are aldehydes, what is their functional group, how we can name them. I mean, the simple common nomenclature as well as the IUPAC nomenclature for aldehydes. So aldehydes are those organic compounds whose general formula is RC double bond O H, or you can say RCHO. So you can see again, it is simple carbonyl in the middle. In the center, we have a simple carbonyl. But the 2 valencies of the carbonyl, other than those bonded to oxygen, are satisfied in a way that one valency is satisfied with a carbon compound, with a single carbon or other carbons chain, alkyl group, and the other valency is always satisfied with a hydrogen. Now this group, this functional group, is called as the aldehyde. This is aldehyde group. As I mentioned, it depends upon the 2 remaining valencies, right? How these valencies are satisfied will decide which family the compound is. So in this case, the aldehyde group is when the carbonyl's one valency is satisfied with a carbon and other valency with a hydrogen atom. It means that the carbonyl inside aldehydes will always be at one extreme side, always on either extreme left or the extreme right. Now this general formula is obeyed by all the aldehydes except for the first aldehyde, because the first aldehyde contains only 1 carbon. The first aldehyde is called formaldehyde, and you have seen it already, formaldehyde. HC double bond OH. You can see both valencies are satisfied by hydrogen atoms because it meant to contain only 1 carbon. So formaldehyde is the structure, and it is also shown as HCHO. IUPAC naming is methanol. Al is the suffix for aldehydes, right? Al. Alcohols, their suffix is ol, like alkenes, their suffix in, alkynes suffix ein, aldehyde suffix, the name will end at al. And the prefixes are like methane, so it's like just alkane. Remove the E and replace that E with Al, like the alkane, right? Just cut this E and replace this E with al. So alkanal. You can say that aldehydes are alkanals, right? So for example, if you have ethane, it becomes ethanol. So methane, ethane, propane, butane, and so on, they become methanol, ethanol, propanol, butanol, and so on. So first aldehyde kind of not obey the main general formula for aldehydes. So it's HCHO. Here one thing more, you might have this question in your mind, why not RCOH? Well, if we make it RCOH, that will be an alcohol. So we will make it like RCHO. But recommended is we make the structure and then we write the CHO stuff, right? This is formaldehyde. Now I will introduce you to a second aldehyde. If the first aldehyde is methanol, what will be the second one? Of course, ethanol. So in that case, you need a carbonyl, one valency by hydrogen and other by methyl. Now methyl, it will have 2 carbons. Okay, if I take another example and I take carbonyl, one valency with carbon and CH2, CH2. Now methanol, 2 carbons, ethanol, 3 carbons, propanol, and if you want to go more, 1, 2, 3, and here we go. This is butanol. So according to IUPAC, this is methanol, this is ethanol, this is propanol, and this is butanol. Now I'll recommend you to be very clear because ol and al are very, very near. So write very slowly and carefully so al is expressed. Now in the common ways, this is formaldehyde, this is acetaldehyde. aldehyde. This is propion aldehyde. And this is butyraldehyde. It's common name, butyraldehyde. Well, let me tell you more. If you go CH3, CH2, CH2, 1, 2, 3, and 4, and the 5th carbon is the carbonyl. Now this is, of course, if this is butanol, can you guess this one? Yep, pentanol. Now pentanol is commonly called valoraldehyde. Now in the you might be liking the IUPAC naming more than the common naming. The IUPAC naming are on the right side and the common naming are on the left side because they make sense. Methanol, ethanol, propanol, butanol, pentanol, and IUPAC is made to make sense because the common naming were not making sense. Okay, they could not actually be used for naming the organic compound that efficiently. That's why we have the IUPAC. But the issue is the common naming used to come from the source of compound. What is the source of compound? Now here I must tell you the formaldehyde name comes from formic acid, which is the first carboxylic acid. Acetaldehyde, the name, comes from acetic acid, which is the second carboxylic acid. Propion aldehyde comes from propionic acid, which is the first carboxylic acid. Now these all aldehydes basically oxidize to carboxylic acids. Any aldehyde, if oxidized, it will convert to a carboxylic acid. So because methanol gives formic acid, so we call methanol also formaldehyde. Because ethanol upon oxidation gives acetic acid, so we call the ethanol as acetaldehyde, because it can somehow convert into acetic acid. Here I want to tell you I'm sorry. Here I want to tell you that how why these names, why such names are given to these compounds. As I mentioned, the common naming used to come from mainly the source of compound. So whatever the source was, the name would go that way. So as I mentioned to you back here in your textbook, the HCOOH, the formic acid, formaldehyde gives formic acid, one carbon. Acetaldehyde, gives acetic acid. So you can see propionic acid is on page 204. Butyric, valeric, and caproic. Now why we call formaldehyde? Because it can give formic acid, and formic acid because it is present in ants. And by that time when formic acid was named for the first, Latin was the main language of the world. So in Latin language, formica stands for the ants, so we call the first carboxylic acid as formic acid, and that's why first aldehyde as formaldehyde, because aldehydes oxidize to carboxylic acids. One aldehyde, methanol, becomes methanoic acid, and so on and so forth. Vinegar, yes, acetone, the Latin name, that's why acetic acid. Vinegar is basically acetic acid. Many of us know this already. Propionic, now remember, propionic and propanoic is different. Propionic is common name because the Greek words protos and fats. The first fats, it was found in the fats. Butyric, Latin word butter, so it's called butyric because from that. Valeric, valera, roots of a plant, so valeric. That's why the 5-carbon aldehyde is called valeraldehyde. Now the 6-carbon is called caproic acid, and if you want to name aldehyde, capraldehyde, because the word capr is from the Latin language. Capr means goat. It was found first discovered in the goat milk. So they were the names. Now these carboxylic acids are nowadays named through IUPAC. Like the formic acid is methanoic acid. Acetic acid is ethanoic, propanoic. Now see this difference. Propanoic is a IUPAC name because OIC is the suffix given by the IUPAC for carbo. OIC, methanoic, ethanoic, propanoic, butanoic, pentanoic, the valeric, hexadecanoic, the palmitic, the 16-carbon and 18-carbon. You can see that the carboxylic acid, the name came from the sources, then converted into IUPAC. But since aldehydes are oxidized to carboxylic acid, every aldehyde can be converted into the corresponding carboxylic acid. That's why the name came. Now you can see that this is HCHO. Okay, when you oxidize HCHO, this oxygen comes from a reaction between highly strong oxidizing agents like K2, Cr2O7 when they are dropped in sulfuric acid concentrated. The oxygen produced bond with the carbon here and form HCOOH. Now this is, guys, this is methanol, and this is methanoic acid. If you want to name common, then what is this? Formaldehyde, and this one is formic acid. So why we call methanol formaldehyde? Because it can convert into formic acid, the first carboxylic acid. So in the same way, if I take here this compound CH3CHO will become CH3COOH, acetaldehyde, acetic acid. So these common names of the aldehydes basically came from the common names of carboxylic acids, because aldehydes can be oxidized with these reagents to carboxylic acids. I hope you get the point, right? Now let's go and let's see how can we name the aldehyde. Now, naming of aldehyde is rather easy than ethers. As I mentioned, you will make mistakes in ethers, and you guys did make mistake in ether, and I like to correct those mistakes. It was fun for me as well. But here I must repeat for you that naming of aldehyde is rather easier as compared to them, because the carbonyl group is always on one side and there's no problem. You can simply count from that side. Since the carbonyl will always be on either end, so that will be first carbon, and so on and so forth. Like, I can make few compounds for you here. Kindly pay attention to me. You can see that CH3, CH2, CH, CH2, C double bond O and H. Now guys, there's no issue of getting confused with the longest chain or whatever, because the longest chain is always be this one, because it will contain the aldehyde group. And there's no confusion again with the numbering the chain. Why? Because the numbering will always start from the carbonyl. So here we go. 1, 2, 3, 4, 5. Now many of you might have already guessed that this is a methyl group, hence the name. We always write the name of the branch first. So this is 3-methyl, right? We've been doing this for a long time. Now the name is like 1, 2, 3, 4, 5. So pentane, pentanol. Like for alcohol, it was pentanol. For aldehydes, it's a pentanol. But point is, you don't have to write one pentanol, because it's always going to be one. So pentanol. Easy, very easy, extremely easy. Just like alcohols, difference is that in alcohols you have to search where's the OH and numbering and all that. Here there's no searching. It's a straightforward, it's a plain, just number it from that carbon and locate the position of the alkyl group, name the alkyl group, name the compound, and make sure the name ends with L and not with ol. If some of you have the L, ol confusing, please write separately. Okay? If you write like a doctor writes, don't do that here. Okay? You can do it after once you become doctors, but not in the exams. So we can see it's very, very easy, and you can see that CH3, 3C, CH2, C double bond O and H. No problem, just to confuse you, it's the same group. Okay, no worry about this one. We have to just open this side. Okay, so you can see that here this carbon is C, CH2, C double bond O, here H. Whether H goes up or H goes down, double bond goes up or down, it doesn't make any difference. 3 alkyl groups, so 3 methyls. Here methyl, N-methyl, and here methyl. Again, no confusion with the numbering the chain, because it is always going to be from this side. It could be from the left side as well, doesn't matter. Many of you might have guessed the name already, I can see that. 3, 3 dimethyl. Be careful with the comma and hyphen. And the name 1, 2, 3, 4, yes, butanol. So how's that? It's easy, very easy. As far as the common name is concerned, the aldehydes don't really have that much common names. it doesn't really matter whether you write a common name or not, because in exams and everywhere they may mainly focus on the IUPAC name. Common names, if common names were so much right, why would there be IUPAC nomenclature? So there was some problem with the common name. That's why they had the IUPAC name. So I hope this is very simple. Aldehydes are very, very simple. You can simply name them from the structure. It's like from the structure is like 1, 2, 3, go. It's no problem. From the name, it's also no problem. Okay. So if I write 2,2 dichloro, right? 3-hydroxy. Okay. Hexanal. Easy. 6 carbons. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. First carbon is always carbonyl. Second carbon, 2 chloros. Third carbon, the hydroxy. And then what do we do? Hydrogen? Yeah. 4 bonds, no hydrogen. 4 bonds, no hydrogen. 3 bonds, 1. You know this, right? So naming from structure or drawing a structure from a name in the aldehydes is super easy. Sometimes it can be difficult when the common names pop out and the examiner gives a common name, because I told you common names not a good success here. Let me make for you one. Isobutyraldehyde. Now, butyraldehyde is simple 4 carbon. Isobutyraldehyde is like 4 carbons, but like this: 1, 2, 3, and 4. Okay. Now the first carbon will be carbonyl, and in the rest you just manage the valences. All right. Now this is isobutyraldehyde. If you want to name it through IUPAC system, 1, 2, 3, 2-methyl propanol. Right? 1, 2, 3. Now let me give you some work right now. New pentyl aldehyde. Now we make a new pentane, right? So how you make new pentane? Carbon, 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 and carbon. That's new pentane. 5 carbon, but 2 of them are branched. That's new pentane. Here will be CH2, right? Now this is new pentane. Now, if you want to make a new pentyldehyde, then this carbon must have carbonyl. So we'll have just 1 hydrogen. So the isopentyldehyde will be 2, 2 dimethyl propanol. Propanol goes 3 carbons in total. So this way, because the most type of naming is based on the naming of the alkanes, and alkanes rules really shine here once again when we try to name the aldehydes. And I hope that you have gotten the idea pretty much clearly. Likewise, similar branches, similar naming, long chains. Branches can be methyl, ethyl, propyl, whatever. So it's not a big deal when it comes to naming the aldehydes from the structures, or naming the or drawing the structures from the names. Okay. Now there's one more thing I must explain to you. Let me do one more here. Alpha, beta, dimethyl pentanol. Now pentanol is 1, 2, 3, 4, 5. First carbon is of course the carbonyl, Now the alpha beta, if you know, this was also once the naming of the organic compounds. The first carbon is not alpha. The carbon which contains which is the part of the functional group, isn't alpha. Alpha is the carbon next to it. So this is alpha, this is beta, right? This is gamma, this is neta. So this was once a naming, right? So alpha beta dimethyl. So alpha has a methyl, beta has a methyl. This is alpha beta dimethyl pentenyl. Pentylaldehyde, because pentenyl is the IUPAC. Pentylaldehyde. But you can just make sense. So this is the naming of the aldehydes and introduction to the aldehydes and why they are named like this. Now I will suggest you some homework in our textbook. Page 193 and 194 has some practice questions. You can see the rules there and practice and reinforce your concepts of naming aldehydes from my lecture as well as from the textbook. Then when you want to exercise, as you all know, page 212, question number 3. In that page, we have done up to ethers up to I think 18. I don't know. Yes, up to 18 we have done, you know, and the aldehydes there are from 22 to 25. Yeah, 22 is aldehyde. Okay, 23 is aldehyde. Just 2 aldehydes. Okay. You can name these compounds for your practice. Okay. Others are ketones, which is just like aldehydes as well. On page 213, you will find aldehydes in the 4th question, and these are from 9th to 12. 9th to 12 are basically naming of aldehyde. So that's the work in the aldehyde family, and this lecture includes understanding of aldehydes, naming of aldehydes, and some assignment as well, which you have to show me by this evening. I want to check if you guys understood or not. I will end this part here, and I will make another part for ketones, and in the end, in part 3, I will compare the aldehydes and ketones. All right, thank you so much. See you in the part 2 today.